We're asked then in question 1 to look at some IR spectra, and we're given 4 compounds labelled 1, 2, 3 and 4. So 1-hexene, 3-pentanone, cyclobutanol and propanoic acid. And we are then asked to match each spectrum to the correct structure. And the first thing we need to do is to look for important functional groups. So we've got 4 compounds here and 4 IR spectra, and we've got to match each of these compounds to either spectra A, B, C or D. So we can have a look at compound 1, and we can see that it's actually the only compound within this group to not contain an oxygen atom. That's important because IR works particularly well for compounds containing oxygen or carbon-oxygen bonds. The remaining 3 compounds then have those carbon-oxygen bonds, either in the form of a carbonyl group, so a carbon double bonded to an oxygen, or in the form of an alcohol group, an OH, so a carbon bonded to an oxygen in an alcohol group. So we can start here with spectrum A, so right at the top. And the first place that I always look when trying to work out these spectra is that region where we are likely to find, or where we will find, an OH peak or an OH absorption band. And this will be at around 3,500 wave numbers, although it can be anywhere between 3,000 to 3,600 to 3,200 wave numbers. And importantly, this tends to be quite a broad peak. So you can see in spectrum A here, there is no OH peak. So that instantly rules out compounds 3 and 4 because they both have an OH group. The next place to look is in this region of the spectrum here, so at around 1700 wave numbers, you will find the Carbonyl peak or the C double bond O peak. This can occur anywhere from kind of 1650 to 1820 wave numbers, and importantly, it's always a very sharp dominant peak. So you can see here that we have a Carbonyl peak at around about 1750 wave numbers. So the compound responsible for this spectrum has no alcohol group, but it does have a carbonyl group. So it can't be cyclobutanol because that's got an alcohol group. It can't be propanoic acid because that also has an alcohol group. So this must be 3-pentanone. Having a look then at spectrum B, and this is not the most exciting of spectra, but firstly we notice again that this does not have an alcohol group. So again that rules out cyclobutanol and propanoic acid. Once again there is no carbonyl peak here. There is a peak at about 3,000 wave numbers that is responsible for CH stretches, and you see this in any compound with carbon and hydrogen, usually quite a broad, intense peak at about 3,000 wave numbers. There's a whole load of information contained within what we call the fingerprint region here. And if I was a diehard infrared spectroscopist, I might be able to determine some information about these compounds from that fingerprint region. But really, we can get more information from things like NMR. So this region, although it contains detail in terms of assigning absorption bands, it's quite challenging. So we can assign this spectrum then to 1-hexene. Finally, spectrum C then, we note there is an OH peak here, and we know that it's either compound 3 or compound 4. And helpfully, there is a very distinct carbonyl peak seen at around 1750 wave numbers. So you see there, very, very distinct, sharp carbonyl peak. And so out of the two compounds that we have left, only compound 4, propanoic acid, contains a carbonyl group, and we can assign that spectrum to propanoic acid. Spectrum D then, you will see, does have a small OH peak, and that's about it. It doesn't have a carbonyl peak. Again, the classic CH stretch is observed at around about 3000 wave numbers, but there's not really much else going on in this spectrum. And so the fact that it has an OH peak and no carbonyl peak means that we can assign it to cyclobutanol.